Now, what happens to the chlorine atom once it gets to the atmosphere? There's a lot of different routes it can take depending on what it collides with because it's so reactive. But and there's even different things that it can do with ozone. But the most important and the most destructive role of chlorine is when it reacts with ozone in the stratosphere where it's cold, in colder parts of the world. And so let me just run through what happens. The chlorine atom will react with ozone to make this these plus 2 oxygen. This is a chlorine oxygen free radical that itself will combine to form one of these strange molecules, chlorine, oxygen, oxygen, chlorine. And then this this particular molecule that is formed when these two free radicals collide will itself also break in the presence of UV light to give chlorine, oxygen, oxygen free radical plus another chlorine free radical. Okay, and then the other chlorine, oxygen, oxygen free radical will break down further to give another chlorine atom plus oxygen. Okay, and so all of these equations net out, this complicated system nets out, if you add everything on the left-hand side with everything on the right-hand side, it adds out down to, or nets out as 2 ozone molecules will be broken down to 3 oxygen. Okay, so the result of this particular reaction is that the chlorine itself, the chlorine atom, is produced in the presence of the ultraviolet light, and it initiates the breakdown of the ozone, but itself is not in the netted reaction. So what happens then is the chlorine atom acts as it's both produced. In this process, it's both produced and consumed. So really what's happening is the chlorine atom is acting as a catalyst for the destruction of ozone. And a catalyst, of course, is a chemical substance that participates in a chemical reaction and influences the speed of the reaction without undergoing permanent change. So one chlorine atom can do a lot of damage because as it's destroying the ozone and breaking the ozone, causing the ozone to be converted to oxygen, it itself is being regenerated. So a single chlorine atom, just one chlorine atom, which is a free radical because it has 7 electrons, can catalyze the destruction of 1 times 10 to the 5th ozone molecules. All right, so it's a catalytic effect. A very, very small amount of chlorine can do a lot of damage. And then because the chlorine atom, it can do a lot of damage, and then it's either going to be carried back down to the lower atmosphere as it continues to move around, or it can be can also be removed from the cycle by reacting with the hydrogen free radical. We know there's hydrogen free radicals up in the stratosphere because of the water vapor that's present. So a hydrogen free radical, if it collides with the chlorine free radical, can remove it from the cycle to give hydrogen chloride, which is stable and is not going to be broken down. And that itself is water soluble and can eventually, if it makes it down to the lower stratosphere, upper troposphere, it can be, rained back down to Earth. So there are ways of removing the chlorine, but not before it does a lot of damage. Okay, so these findings that that this kind of series of events can happen with the chlorine atom acting as a catalyst to remove the ozone from the stratosphere was published in 1974. Okay, so after the chlorofluorocarbons had been used for about 20 years, wide scale all over the industrialized world, in cans of hairspray and industrial processes and making plastics and in refrigeration units all over the world. And because it was so stable and non-toxic, when somebody needed to recharge their car air conditioner or their home air conditioner, they would just release the Freon into the atmosphere and recharge it with more Freon. So it was just kind of like freely spewing into the atmosphere until 1974, when people realized, oh no, this could cause a problem with the ozone in the upper atmosphere, and it was already well known that ozone screened ultraviolet light. So further analysis, once they realized that was a problem, then people started really looking to see if there really any correlation. I mean, once the chemistry was understood, is there really any correlation to where, is there any correlation between the, the production of chlorine atoms in the atmosphere and really the destruction that was? And so they went out and did more careful analysis, testing both the stratospheric ozone and the stratospheric chlorine. And the stratospheric ozone, of course, is O3, and the stratospheric chlorine was in the form of one of the intermediates in the process, this free radical chlorine oxide molecule. And what they showed was, based on the latitude, degrees south latitude, that if the stratospheric ozone concentration was relatively high, the stratospheric chlorine concentration was relatively low, and as the stratospheric chlorine concentration increased, the stratospheric ozone concentration decreased. So they had evidence that supported the theory, was that the chlorine could act as a catalyst to destroy the ozone, to convert the ozone to oxygen in the stratosphere. So it's sort of the smoking gun data here to show that there was a direct correlation between the concentration of the chlorine in the stratosphere and the concentration of the ozone in the stratosphere. Now, before people can be convinced to do something about the fact that we were putting this particular chemical in the environment, they had to rule out, are there any other natural sources of chlorinated carbon compounds in the environment? Because just because it's there doesn't mean that people put it there. And so what they found is, no, to make that dramatic of a difference, there really aren't any natural sources. I mean, you can get chlorine from the oceans and from volcanoes, but the types of chlorinated carbons that come from the oceans and from volcanoes are water soluble, and those chemicals would never reach that high concentration. The chlorofluorocarbons are not water soluble, so they don't get washed out in the rain, whereas the naturally occurring chemical compounds are water soluble, and would get washed out by the rain. So it's truly a smoking gun that these chlorofluorocarbons were the source of chlorine atoms that caused the decrease of the ozone in the stratosphere. So now, next time, now that we know that it's the fall of the chlorofluorocarbons, we still have not explained why there's the quote-unquote hole over the Antarctic.